In this video, we'll be doing an example of a half-life problem. We'll first use the formula for exponential growth and decay, and then we'll do the same problem with the half-life formula. Our problem is the half-life of carbon-14 is about 5,730 years. If 1 gram of carbon-14 is present in a sample, how much will be present in 10,000 years? Now our exponential growth and decay formula is y equals y sub 0 times e raised to the kt, where y is the amount after t years, y sub 0 is the amount at t equals 0, so the initial amount, k is a constant, and then t is the amount of time. So if we substitute in here, we have our initial amount, y sub 0 is 1 gram. Our amount after t years will be half of that, because we first have to find what our constant k is equal to. Our t is 5,730. So let's go ahead and substitute these numbers in. Y we said was a half. Y sub 0 is 1. We're looking for k, and then t is 5,730. So our problem simplifies to 1/2 equals e to the 5,730 times k. Now if we ln both sides, because our variable's up in the exponent, we have ln 0.5, which is your 1/2, equals ln e to the 5,730k. Now we'll use the rule that says we can bring this exponent out in front of the logarithm. So ln 0.5 is equal to 5,730k times ln e. Now ln e is equal to 1, so we can divide both sides of this equation by 5,730 to get k is equal to ln 0.5 divided by 5,730. Now I'm not going to do this in a calculator because I want to keep it as accurate as possible. What I'm going to do now is plug back into my formula. I want to know how much carbon-14 I'm going to have after 10,000 years. So my y is equal to, and again the initial amount is 1, e to the k is ln 0.5 divided by 5,730, and my time now is 10,000 years. Now I can get my calculator out and get an approximation for this. I want e raised to the ln 0.5 divided by 5,730 multiplied by 10,000. And it looks like I'm going to have approximately 0.298 grams. Now let's use our half-life formula. The half-life formula just requires that I put my time in the numerator of the exponent and my half-life in the denominator. So I should get the same amount here, the 0.298 grams. So we have 1/2 raised to the 10,000 divided by, and then the half-life we know was 5,730. So 1/2, like 0.5, raised to the 10,000 divided by 5,730. So again, 0.298.